All right, so the title of our notes is Simplifying Trigonometric Expressions. And what we're going to do is we're going to use trig identities. Okay, some of the trig identities we already know. Some I'm going to teach you today. And we're going to use these trig identities to simplify other trigonometric expressions. So some of the ones that we know already is that the tangent of theta is sine theta over cosine theta. We know that the cotangent of theta is the reciprocal of that, and so we could write cosine theta over sine theta. We know that the reciprocal identities, that 1 over tangent is the tangent. Sorry, not the tangent. What is it? The cotangent. And 1 over the cotangent is the tangent. 1 over sine is the what? Cosecant. 1 over cosecant is the sine. And then we could do this one more time. 1 over cosine is the secant. And 1 over secant is the cosine. Okay, so I'm going to give you some simplifying examples that would use these trig identities. So example 1. I want you to simplify. And for part A, very simple. We'll say the cotangent of theta times the sine of theta. Okay. So when you're trying to simplify, so here we have two expressions multiplied together. Trying to say, well, is there a way to combine them and make one out of the two? And one technique that you want to try, especially in this case, is to change everything back into just terms of sine and cosine. Because everything's related to sine and cosine in one or way or another. And we want to change everything in terms of sine and cosine. So that cotangent we could rewrite as what? 1 over tangent's one way, but that's not in terms of sine and cosine. You could also write cosine over sine. So I'm going to change the cotangent to cosine over sine. And that's multiplied now with sine. And if it helps, you can make that sine over 1. We're going to have a lot of fraction work in this, so we need to remember how to multiply fractions and add fractions. It'll be helpful with what we're doing here. So when you multiply fractions together, you multiply top with the top. So we get cosine theta times the sine of theta, and sine theta times 1. And we can reduce the fraction. So we divide by sine theta, and we end up with cosine theta. Okay, so we've simplified it down. Cotangent theta times sine theta is actually equal to cosine theta. Yeah. Next example. Sine theta times the tangent theta times the cotangent theta times the cosecant theta. So again, a technique when you're simplifying is to first get everything in terms of sine and cosine. There are other techniques out there, but if you're not sure, if you're at a dead end and not sure what to do, you can always fall back on this one. So sine's already in terms of sine. We'll leave it sine theta. I'm going to put it in fraction form. Tangent is what? Sine over cosine. Cotangent is cosine over sine. And cosecant is 1 over sine. Oops. All right. So when you multiply, really what happens is all this becomes one big fraction, right? Everything in the numerator, everything in the denominator, if we extended this all the way through, it's one big fraction. And so you can start to see, I got 2 sines and 1 cosine in the numerator. I got 2 sines and 1 cosine in the denominator. And if you want to divide a cosine out or divide a sine out or another sine out, we all end up with 1 over 1, which is just 1. So multiplying all that together simplifies down to 1. I'm going to give you 2 more to try on your own. You can get these. Try the tangent of theta divided by the secant of theta. And try the secant of theta minus the sine of theta times the tangent of theta. All right, what are we getting for part C? Sine. Okay. One way to do this, change everything back into sine and cosine. So tangent is sine over cosine divided by, I'm just going to write divided by this way. Secant is 1 over cosine. And so when you divide a fraction by a fraction, you keep the first fraction the way it is, so sine over cosine. You change it to a multiplication problem and multiply by the reciprocal of the second fraction. And here we could divide out cosine, and we end up with sine. So sine theta is correct. How about the second one, part D? Anybody able to simplify that down? Yeah, Timothy? 2 sine minus 1 over cosine? You get something different? 1 minus sine squared over cosine. Okay. So if you have a fraction, if you can get into one fraction, it's better than having 2. And so part of this is learning, when do I stop? How do I know when it's simplified down? First step, move everything in terms of sine and cosine. So secant is 1 over cosine. Sine over 1. Tangent is sine over cosine. Okay. And when I simplify this down a little bit, this becomes 1 over cosine theta minus sine squared theta over cosine. And because when you're adding or subtracting fractions, you make sure the denominators match, and they do here. And because they're both the same, I can add or subtract the numerators. Here, in this case, it's 1 minus sine squared theta all over cosine. At this point, that's as far as you can go. You need something else, because there actually is more that we can do. So we're gonna come right back to this. And this leads into the next identity that I need to show you, called the Pythagorean identities. Okay, so to be continued, we'll come back to D. Okay, so the Pythagorean identities come from the Pythagorean theorem and from the unit circle, what we learned about the unit circle. So when we were working with the unit circle last unit, we would draw right triangles in that unit circle. What was the hypotenuse of that triangle? 1. And let's call this angle theta, the reference angle. And we had some x value here and some y value here. And we learned that x was what? The cosine of theta. And y was the sine of theta. Okay. So if I use the Pythagorean theorem on this right triangle, I get y squared plus x squared equals what? 1. 1 squared, which is 1. And y squared, well, if y is sine, we could change this to sine squared theta plus cosine squared theta, and that will always add up to 1. It's true. So you try it with 30 degrees. If you go sine squared of 30 degrees plus cosine squared of 30 degrees, you can figure out what those are. You get 1. Try it with 45, you get 1. Try it with 60, you get 1. Try it with any angle, it will always be 1 because of that Pythagorean theorem. So that's an identity. That's our first Pythagorean identity. Sine squared theta plus the cosine squared theta equals 1. That's the easiest one to memorize. And you will have to memorize them. Now, I'm going to do a little more work on the right-hand side here. If I take this expression, sine squared plus cosine squared equals 1, and if I divide each one of those by sine squared theta, which we're allowed to do because it's an equation and just dividing both sides by sine squared theta keeps it equal. Exactly 1. Okay. So what is sine squared theta divided by sine squared theta? 1, right? Same quantity divided by the same quantity is 1. What is cosine divided by sine? That's the cotangent, and it's squared because cosine and sine are squared. And what's 1 over sine? Cosecant squared theta. So that's our second identity, and it comes from the first identity, just dividing everything by sine squared. So I'm going to write that 1 plus cotangent squared of theta is equal to the cosecant squared of theta. And then the last of the three come from a similar process. If I again start with sine squared theta plus cosine squared theta equals 1, and this time instead of dividing by sine squared, I'm going to divide each one by cosine squared. And what's that gonna create? What do I get? So what's sine over cosine? Tangent squared theta plus 1 equals secant squared theta. Okay, so that's the third identity. I'm going to write that under the Pythagorean identity. So tangent squared theta plus 1 equals the secant squared theta. And the last two sometimes are hard to remember, so you can either derive them each time, or you can remember cotangent goes with cosecant because when you put them in terms of sine and cosine, they both have the same denominator. Cotangent is cosine over sine, sine's the denominator. Cosecant, sine's the denominator, right? Same idea with tangent and secant. If you change those in terms of sine and cosine, both of them have cosine as the same denominator. That may help you remember what goes with what, may not, but you want to know these Pythagorean identities. You also want to know other variations of these identities, meaning if you take one of them, you can rewrite it in different forms. So like I could solve the first one for sine squared, and I get sine squared theta is equal to what? If you solve that for sine, if I got rid of the cosine squared, I subtracted cosine squared from both sides of the equation, I'd get 1 minus cosine squared theta. It's the same thing as sine squared plus cosine squared equals 1, but it's solved for sine. Or I could solve it for cosine. If I write cosine squared theta, what would that be? 1 minus the sine squared theta. So that's what I mean by other variations. They all mean the same thing, but they look a little differently. So now let's go back up to part D. What do you notice? That numerator is 1 minus sine squared theta. And we just worked through these Pythagorean identities, and we found that the 1 minus cosine squared theta is equal to what? Sine squared. So now that we know the Pythagorean identities, we can go back to D and, all right, 1 minus sine squared is what? Cosine squared. This is cosine squared over cosine, which just comes out to be cosine. So now by knowing that identity, we are able to simplify this way down. Look at this cosine theta. Okay. Let me give you some other examples that involve these Pythagorean identities. Call it example 2. Again, instructions are to simplify. So part A, we're going to look at secant squared theta minus tangent squared theta plus the cotangent squared theta. Okay. So our first technique that we learned in example 1 was change everything to sine and cosine. And that could help. But now that we've seen Pythagorean identities, our second technique is using Pythagorean identities to simplify things down. And the problem itself that's given to you can clue in what, can give you some clues to what technique you need to use. So if you notice that you're working with things that have squares, like secant squared and tangent squared and cotangent squared. So if you see that, and if you see plus signs or minus signs, so there's more than one term, that gives you a clue that, yeah, I might need to think about these trigonometric identities. Okay, so I want you to look at those trigonometric identities and see if you can apply any of those to this problem to simplify it maybe a little bit. Anybody see one that would work? Yeah. Okay. So if we look at notice we got tangent squared plus 1 equals secant squared, and so we would like, that's got tangent squared and secant squared. And here I got a tangent squared and a secant squared, right? So if I rewrite this one, I can rewrite it as 1 equals what? Secant squared theta minus tangent squared theta. So I just subtract tangent squared from both sides. And that's what we have. Secant squared theta minus tangent squared theta equals 1. So I can go to this problem, and I can replace this piece right here with just a 1. So now I'm down to 1 plus cotangent squared theta. Which is a nice simplification there, right? And then we still have a squared, and we still have plus sign in 2 terms. So is there another identity that might be helpful? Yeah. Equals what? Cosecant squared theta. So this whole piece here equals cosecant squared theta, and now we simplified it down. So by looking at the Pythagorean identities. Okay, here's another example I want you to try. Part B. Secant squared theta divided by secant squared theta minus 1. Okay, what are you trying? Any ideas what to do? Yeah, Lena. Okay, so the numerator we're going to leave alone, but the secant squared theta minus 1 is the same thing as what? Tangent squared theta. You guys see why? You go back up to, if you solve for tangent squared theta on this third one, you get secant squared theta minus 1. Okay, so that's a good move. And then what's the next step? Yeah. So at this point, trig identities are not going to be helpful to you anymore because there's no plus or minus signs here. You want to go back to our first method, which is get everything in terms of sine and cosine. So secant is 1 over cosine, and it's squared, divided by tangent. Tangent is sine squared over cosine in this because it's tangent squared. And when we divide, you can change it into a multiplication problem. And when you multiply, you just ends up becoming one big fraction here, right? And we can reduce this fraction to 1 over sine squared theta. And don't leave it that way. You don't want to leave it 1 over a trig function because you have another representation for 1 over sine. What is it? The cosecant. So this is cosecant squared theta. Okay, another example. The cosine of theta times the secant of theta minus the cosine of theta divided by the secant of theta. Simplify that. Okay, so here there's nothing squared at first. And so our technique is to get everything in terms of sine and cosine. And so cosine's already in that form. Number 1, secant is 1 over cosine minus cosine divided by secant, which is 1 over cosine. right? So the first part, we can make this one fraction when you multiply and reduce that fraction. So that first part just becomes 1 minus cosine theta over 1, and change your division problem into a multiplication problem by flipping that second fraction over, cosine theta over 1. And so we end up with 1 minus the cosine squared theta, bless you. And now when we're in this form, this should remind you, or should trigger, hey, this might be a Pythagorean identity. Because cosine squared plus sine squared is 1. And if we manipulate that around, you get the sine squared is actually equal to 1 minus cosine squared. And so this comes out to be sine squared theta. There we have it. Okay. Let's look at one last one. Let's do the secant theta plus 1 times the secant of theta minus 1. Okay. On this one here, you can try things individually, but sometimes we don't see any Pythagorean identities. Always look for the Pythagorean identities. If you could see those, that would simplify it nicely. And we don't see that here because there's no squareds. But if we multiply this out, secant times secant, I get secant squared theta, which is that squared part that I like. Secant times -1, negative secant theta. 1 times secant theta is positive secant theta. And 1 times -1 is -1. And we can add the negative secant theta and the positive secant theta, and that adds up to 0. So now we've simplified this down to secant squared theta minus 1. And from our trig identities, we know that the tangent squared theta plus 1 is equal to the secant squared theta, right? So if we subtract 1 from both sides, we end up with the tangent squared theta is secant squared theta minus 1. And so now we can replace this with the tangent squared theta. And we got our answer.